Okay, this is a good hydraulic lift problem. So this is what they do at the mechanic shop. They've got this lift here. They're able to lift a car up here. A car weighs a lot with a small amount of force here. They can do this with their foot. Just push down here and lift up the whole thing. The reason they're able to do this is any extra pressure on the fluid is distributed equally throughout the entire fluid. So, I mean, if we just leave the fluid alone, if we don't have anything on top of it, of course, the pressure at the bottom is greater than the pressure at the top. It's because pressure depends on depth. But if we compress the fluid, any additional pressure we're applying is equally distributed everywhere. Everybody gets the same pressure. And remember, pressure is force divided by area. So if I have a small area here with a medium-sized force and a big area here, I can lift a big force here. So here's our setup. Read the question. Okay, hopefully you've done that. We want to find the ratio of the two radii of this disk here and this disk here. And we're going to use, in this problem, they use little p to represent pressure. It's more standard to use capital P, but I'm going to follow their convention here and use little p. The pressure everywhere in the fluid, the additional pressure from this force, will be equal. Pressure is force divided by area. We're assuming here these are circles, so the areas are pi r squareds. And then we just do a little cross multiplying here and we get a ratio of the two radii squared, or a ratio of the radii by taking the square root. The force of the car is its mass times gravity, g. The force we applied over here on the left side was 110 newtons, so we get a ratio of about 12. It was 11.9 something. So this disk here, if it's 12 times larger than this disk in radius, then 110 newtons is able to lift up a car. And 110 newtons is hardly anything. You can do that with your foot.